Today's lesson looks at how we can use the double angle formulae in a different way. So we learned the double angle formulae, ones that looked like these, and we also had the tan A plus B and A minus B ones. Today we're just looking at the sine and the cos ones and how we can rearrange those cleverly. Now we've used them a few different ways. We've generated the double angle formulae from them. We've also generated the T formulae from them. So this time we're generating a different set of formulae. And this lesson is called Products to Sums because it looks at how we can take the sum or the difference of some angles and change it to the product of some trigonometric functions. Okay, so basically I want you to help me generate these formulae so that you can see where they came from. We're only looking at the sine and the cos of A plus B or A minus B. And if I call each of these four equations 1, 2, 3, or 4, then I'm going to either add or subtract the first two, and then I'm going to add or subtract the second two and see what I get. So adding equation 1 and equation 2, I can see that I'm going to get on the left-hand side the sine of A plus B plus the sine of A minus B. I've just added these two parts together here. And what I'm going to get is all of this plus all of this. So let's have a look at that. We're going to get sine A cos B plus another sine A cos B. That's going to give us 2 sine A cos B. And then the other term's going to disappear because if you've got cos A sine B and you add negative cos A sine B, you've got nothing there. So we get this nice simple answer. Okay, what happens when we subtract equation 2 from equation 1? Well, we're going to get this term minus this one, so they're going to disappear, and we're going to have cos A sine B minus negative cos A sine B, and that will give us 2 cos A sine B. So a really similar result, but just around the other way. All right, if we add equation 3 and equation 4, clearly the left-hand side gives us cos A plus B plus cos A minus B. But the right-hand sides, if we add these together, we've got one of these plus another one, so we'll get 2 of those, 2 cos A cos B. And here, if we have negative sine A sine B and we add sine A sine B, those will disappear each other, so we won't get any of that term at all. And then subtracting equation 4 from equation 3, clearly we'll have this subtracted from that, so those will disappear. But over here we'll have negative sine A sine B minus another sine A sine B. We're going to have negative 2 sine A sine B. So those were fairly easy to generate from these. But we're going to go ahead and change them just a little bit more. And you can be reassured that what we're going to write is on your formula sheet. So you don't need to memorize these, but you do need to know how to derive them and how to use them. Now you can see that we've derived these simply by adding and subtracting these equations. And these ones are, well, this one and this one are on your formula sheet. These two can be easily generated by just changing the signs in those ones. And as with any formula, it's important that you understand where it came from and that you're not just taking my word for it that an identity is actually true. Now, this topic here is called products to sums. So you'll see here that what we've got is the sum of some things, and what we've generated is a product. That's why I'm going to rewrite these around the other way, so that we can actually start with the product and use it to generate a sum. So if I wanted to just write down sine A cos B here, I'll use black for these ones. Now these are the ones that are actually on your formula sheet, so we're going to write them in our books like this. Now you can write these ones as well, of course, and putting them beside each other probably makes sense, but it's these ones here that are on our formula sheet, so we'll learn them this way. Now if you wanted a formula for sine A cos B, wouldn't you say that you needed to halve this side, so it's going to be equal to half of all of this side? So that's exactly what we write. Hold on, let me move you over a little bit. So we'll have half, and then some brackets, the sine of A plus B plus the sine of A minus B. Oops, minus B, like that, close brackets. So that's then a formula that takes us from a product of two trig identities into a formula that has some sums in it. And that's what we mean by products to sums. Now, why don't you pause the video and see if you can now generate a formula for cos A sine B, cos A cos B, and sine A sine B using the rest of these. Then you can check if your work is correct. And you should have now generated the rest of these formulae. So having a quick look at them, we've got sine A cos B, cos A sine B, cos and cos, sine and sine. And in each case, we've got a half out the front because all of these had a 2. Notice that the last one there has a negative out the front because this one had a negative. And then we've either got the addition or the subtraction of any of these two equations. Now, it's not a bad idea to have a look at your reference sheet now because that's what you're going to have in all of your tests and exams, and actually note where these things are written down so that you can see that they're just underneath the double angle formulae for the sine and the cos and the tan of A plus B. And underneath those, you've got the T formulae, and then underneath those, you've got these formulae here for the products to sums. And it's really reassuring to have that reference sheet out when you're doing your work from your textbook so that you're getting used to using the exact tools that you'll have with you in an exam. Now, we use these products to sums identities, and I've left them on the board here for easy reference. We use them to basically prove identities or just to rearrange expressions as required. So, for example, here we need to convert sine of 7x multiplied by the cos of 3x to a sum of sine functions. So, the sine of something, the cos of something, here I can see that A is 7x and B is 3x. Now, you don't need to write that down all the time, but when you're just starting, it's not silly. And now I can see that I'm using this one because it's the sine of something multiplied by the cos of something else. And then I can go ahead and just write out my identity using my A and B. So I can see that what I'll have is half. Now, important you don't forget the brackets. You can use these as big square brackets or you can make them round brackets. Just make sure you don't forget them because that half needs to apply to both bits. So we have half of the sine of A plus B, so 7x plus 3x is 10x, plus the sine of A minus B, which will be 4x. Now you can leave it like that. Obviously this is the same as the half of sine 10x plus half of sine 4x, but it's okay to leave it like that because really writing it like this isn't necessarily any neater or better. And a second example here, I need to convert sine of 7x, sine of 3x to a sum of cosine functions this time. So I can see I have the sine of two different angles multiplied together. So I'm using this formula down here, and I can see here that my A is going to be 7x and my B is going to be 3x. So I can pretty much just launch straight into this now and make sure I don't forget my brackets. I've got negative half, and then I have the cos of one angle plus the other, 7x plus 3x is 10x, minus the cos of A minus B, and 7x minus 3x is 4x. So a similar looking result. And again, I can just leave it like this. Expanding the brackets doesn't really take me anywhere further.